All right, so we're looking at this polynomial, f of x equals 8x cubed minus 6x squared plus 5x plus 3. And we are supposed to determine the Taylor polynomial, T3, of degree 3 for the function f of x, for that function, centered at a equals 1. So we have a little chart that we like to use for these to organize our work. So I'm just going to start writing those down. So we start with derivatives at x. Then we have derivatives at the value we're centered at. So we're going to have 1 in this case. Then we have the coefficient. And then we have the power on x minus a. All right. So my derivatives, start with taking derivatives. So because I'm looking for T3 of x, I'm going to need 3 derivatives. So I start with f of x, which is 8x cubed minus 6x squared plus 5x plus 3. And then the first derivative is 24x squared minus 12x plus 5. Second derivative is 48x minus 12, and the third derivative is 48. Now I'm going to plug into each of these functions, f, f prime, f double prime, and f triple prime. I'm going to plug in the 1, the a equals 1 where I'm centered. So f of 1, if I plug in a 1 here, I get 8 minus 6, which is 2, plus 5 is 7, plus 3 is 10. And then plug a 1 into the derivative, and I get 24 minus 12 is 12, plus 5 is 17. F double prime of 1, 48 minus 12 is 36. And then f triple prime of 1 is 48, because f prime of anything is 48. All right, so my coefficients are going to be each of these f values over some factorials. We start with 0 factorial, and then we increase by 1 on each term. So this is going to be 10 over 0 factorial, which is 10. 17 over 1 factorial, which is 17. And this is 36 over 2 factorial. 2 factorial is 2, so that becomes 18. And then 48 over 3 factorial. 3 factorial is 6, and 48 over 6 is 8. And then my powers on x are going to be the 0 power, which is just a 1, and then the first power, and the second power, oops, that's supposed to be a 1, and x minus 1 to the third power. Okay, so then my final T3 of x, I'll write it up here, is the coefficient times the x minus 1 to a power. So we're going to have 10 times x minus 1 to the 0, which is 1, so I'm not going to write that down, plus 17 times x minus 1, plus 18 times x minus 1 squared, plus 8 times x minus 1 cubed. All right, so that's my third degree Taylor polynomial. It's supposed to be a good approximation of the function when I'm near a equals 1. So let's look at the error for T3 to approximate f. And the hint says to multiply out T3. So let's see, if I multiply everything in T3 out, I have 10 plus 17x minus 17 plus 18 times x squared minus 2x plus 1 plus 8 times x minus 1 cubed. Let's see. I'm going to distribute an x minus 1 to x minus 1 squared. So I get x cubed minus 2x squared plus x That's distributing an x, and then I'm going to distribute a minus 1. So I have minus x squared plus 2x minus 1. And I'll simplify that in the next line. 10 plus 17x minus 17 plus 18x squared minus 36x plus 18 plus 8x cubed. I'm going to combine my minus 2x squared and my x squared here, so it's minus 3x squared times my 8 is minus 24x squared. And then I have an x and a 2x, so that's 3x multiplied by 8 is 24x. And then minus 1 times 8 is minus 8. All right, so now I just combine my like terms, and I get 8x cubed. 18 minus 24 is negative 6, negative 6x squared. And then my x's, I have 17 minus 36 plus 24, which is 5. And then for my constants, 10 minus 17 plus 18 minus 8 is plus 3. And that is the function we started with. So it looks like T3 is a perfect approximation for f of x, which makes sense because we were building a third-degree polynomial to approximate a third-degree polynomial. So it would make sense that they would be the same polynomial. So my error in this case is 0.